Welcome to qnawire.
Okay, so we've got various structures, and we are asked to find which one can't be nucleophilic. So let's just run through these real quick and consider, whether it makes sense for this thing to be nucleophilic. Bromine has a negative charge on it. That's going to want nucleuses. Remember, nucleus means positive charge. Nucleophile means it wants positive charge. It makes a lot of sense that something with a negative charge formally would want positive charge. We want to eventually everyone wants to be neutral, so if you are negative, you're looking for positive things to balance you out. Okay, so bromine very clearly can be a nucleophile. Well, what about this double bond here? That's kind of weird. Is that nucleophilic? Well, yes. So you may have seen the example of, if we had water here, I'll draw it a different way. Double bonds can open up as such. And, eventually this will be a positive charge here, and then water comes in and attacks it in another step. But the hydration of double bonds starts by the double bond acting as a nucleophile and going to steal a proton from water or an acid. So double bonds they want something positive. In fact, you can kind of think of this double bond as being partially positive on one side and partially negative on the other. But this partial negative is what's going to open up and go steal a proton from somewhere, right? Okay. So yes, double bonds can be nucleophilic. Water, it's got a lone pair, and we're used to seeing water. If we have some acid around, let's make this H2. Whole thing's positive. We're used to seeing this. Water and alcohol groups love to go steal protons from other places, and they do that using the lone pair on oxygen. Once again, this is partially negative and partial positive there. All right, so nucleophilic oxygen, yes, oxygen's a great nucleophile. What about this carbocation? Well, here's something that probably can't be a nucleophile, right? It wants positive charge. This already has a positive charge. If anything, this wants negative charge. Carbocation is not nucleophilic. It's electrophilic, in fact, right? So an electrophile cannot be a nucleophile.